Welcome back to Data Science series. Today is day 9. We have some exciting topics lined up for you. We were diving into the world of linear algebra with dot products, matrix multiplication, determinants, eigenvalues, and eigenvector using NumPy. Let's get started. First, let's talk about dot product. The dot product is an algebraic operation that takes two equal length sequence of numbers and return a single number. It's often used in physics and engineering to calculate projections, among other things. First, let's import the NumPy library. This library helps us perform mathematical operations efficiently. Import NumPy as np. Next, we will define two vectors. In this example, we will use vectors, vector A and vector B. We can calculate the dot product of these two vectors using the np.dot function. Here, let me run this. Let's print the result to see the dot product of our vector. And we got 32. Here in our example, the calculation is 1 multiplied by 4, then 2 multiplied by 5, then 3 multiplied by 6, which is 32. Next up is matrix multiplication. This is a function operation in linear algebra, essential for various applications in data science, such as transforming data sets and solving system of linear equations. In NumPy, we use the np.matmul function for matrix multiplication. Let's see an example of it. First, let's import the NumPy library. This library helps us perform mathematical operation effectively. Let's run this. Next, we will define two matrices. In this example, we will use matrix underscore A and matrix underscore B equal to a 2D array. We perform matrix multiplication using the np.matmul or np.matmul function. Here, the matrix multiplication is defined as where each element of the resulting matrix, called my variable matrix underscore product, is the dot product of the corresponding row of matrix A and the column of matrix B. Let's print the original matrices and the result of their multiplications. And that's it. We have successfully performed matrix multiplication using Python and NumPy. Matrix multiplication is a crucial operation in many applications, and now you know how to compute it efficiently. Now, let's move on to the determinant. The determinant is a scalar value that can be computed from the element of a square matrix. It provides important properties about the matrix, like whether it's invertible. In NumPy, we can calculate the determinant using the linalg, which is the short form of linear algebra.det function. First, let's import the NumPy library. This library helps us perform mathematical operation effectively. Next, we will define a matrix. In this example, we will use a 2 into 2 matrix. We can calculate the determinant of a matrix using the np.linalg, which is the linear algebra.determinant, in short det. Then inside of a parenthesis, put the matrix. Let's print the original matrix and its determinant. We find the determinant of our matrix, which in this case is -2. That's it. We have successfully calculated the determinant of a matrix using Python and NumPy. The determinant is a crucial operation in many linear algebra applications, and now you know how to compute it effectively. Finally, let's talk about eigenvalues and eigenvectors. These are crucial in understanding the properties of matrices and are used in various applications like principal component analysis. In NumPy, we can compute them using np.linalg.eig function. Let's take a look. First, let's import the NumPy library. This library helps us performing mathematical operation effectively. Next, we will define a matrix. In this example, we will use a 2 into 2 matrix. We can calculate the eigenvalues and eigenvectors of the matrix using the np.linalg.eig function. Eigenvalues and eigenvectors satisfies the equation where A is our matrix, V is an eigenvectors, and the lambda is the corresponding eigenvalues. Let's print the original matrix, its eigenvalues and eigenvectors. And that's it. We have successfully calculated the eigenvalues and eigenvectors of a matrix using Python and NumPy. Eigenvalues and eigenvectors are crucial in many applications, from solving differential equation to understand the properties of matrix. That's it for day 9 of our data science series. Today we covered dot product, matrix multiplication, determinant, eigenvalues and eigenvectors using NumPy. Don't forget to like, subscribe and hit the bell icon so you won't miss any future videos. If you have any question, drop them in a comment below. Thanks for watching.